Last time we talked about quadratic functions in standard form, and we talked about finding the vertex, and we also talked about how to use the a value to find whether there is a stretch or compression. And also we said that there was a reflection. It would open down if that value was negative. So this time we're going to talk about X-intercepts and Y-intercepts. Let's start with Y-intercepts. Now a function will only have one Y-intercept, and the Y-intercept is going to be on the graph on the y-axis. So it'll be where the parabola intersects the y-axis. So the value for x, where it crosses, is going to be 0. So at x equals 0, y equals a number. That's going to give us our y-intercept. So what we could do to find the y-intercept is we could sub in 0 for x. Now what you'll notice when you're in standard form and we sub in 0 for x is that we have y equals a times 0 squared is 0, b times 0 is 0, and then we have c left. So the ordered pair where we get a y-intercept in standard form is going to be 0, c. That c value, or the constant term, in the standard form equation. And you might also write down there is only one y-intercept. Please note that your y-intercept needs to be given in ordered pair form, 0, c. Now let's talk about x-intercepts. X-intercepts are not as easy to find as y-intercepts. Now the x-intercept is where the graph would cross the x-axis. So we could have more than just one at times. We could have a graph where the parabola is sitting right on the axis. In fact, the parent function does that. So we could have one x-intercept. Or we could have a graph where the parabola is kind of up above the x-axis and have no x-intercepts. Or if the parabola opens down and is below the x-axis, we could also have 0 x-intercepts. So we could have one x-intercept, 0 x-intercepts, or we could have a graph that crosses the x-axis twice. So we could have 2 x-intercepts. So x-intercept, there may be 0, 1, or 2, depending. The way that we find x-intercepts is that we're going to sub in 0 for y. Just like we found y-intercepts by subbing in 0 for x, we're going to get x-intercepts by subbing in 0 for y. Now in standard form, if I sub in 0 for y, that's really going to be setting it equal to 0. So it's really going to be 0 equals ax squared plus bx plus c. Now that should look familiar. This is a quadratic equation that we need to solve. So we set this equal to 0, so 0 equals ax squared plus bx plus c, and then we're going to solve for x. Now we had an entire unit that we studied how to solve quadratic equations. The first way that we solved quadratic equations was by factoring. After we solved by factoring, we used the square root method. Now the square root method will not work unless there's just a squared thing. So the square root method is rarely used. Or we could complete the square. And the fourth and final method that we used to solve quadratic equations was the quadratic formula. Now, of these four methods, completing the square and quadratic formula will always work for you. Factoring will work sometimes. So my suggestion is if you look at that equation and it looks, it's easy to factor, you can factor it without too much work, then go ahead and do that. If you can't, then you might think about completing the square or the quadratic formula, whichever one works better for you. So let's go ahead and look at an example of finding the X and Y-intercepts in standard form. So y equals x squared plus 4x minus 1. And I want to find the X and Y-intercepts. Probably the easiest one to do first is to find the y-intercept because it's just that constant term when it's in standard form. So the y-intercept will be 0, comma, the constant term, which is -1. So 0, -1. Then to find, let's label that y-intercept, then to find the x-intercepts, what we're going to do is set 0 equal to the x squared plus 4x minus 1. And we're going to solve this using either quadratic formula, factoring, square root method, or completing the square. I'm going to suggest that we use quadratic formula. So we'll just put that there, and we'll go ahead. X equals the opposite of b plus or minus the square root of b squared minus 4ac divided by 2a. So we're going to go through and simplify that. And we get -4 plus or minus the square root of, this becomes 16 plus 4, so 20 all over 2, which is -4 plus or minus 20 breaks down into 10 times 2. 10 would be 5 times 2 times this other 2 that we still had before. So the 2's come out, turn into a 2. The 5 stays in. So we have 2 square roots of 5 and then divided by 2. So we can simplify 2, 2, and 2. So x equals -2 plus or minus the square root of 5. So our x-intercepts will be -2 plus the square root of 5, comma 0, and -2 minus the square root of 5, comma 0. Now when we start graphing these functions on the coordinate plane, what you're going to need to do is when you have x-intercepts that look like that, you'll want a decimal approximation. So we'll also calculate -2 plus the square root of 5, which is 0.236, and -2 minus the square root of 5, which is -0.236. So I'll go ahead and also write these as 0.240 and -0.240. But when you're finding them, you should always include the exact answers. This is the one that I'm looking for, but then you're going to use decimal approximations to graph. Because it's kind of hard to graph -2 plus the square root of 5. So we need a decimal. Now let's look also at finding the x and y intercepts when you have a parabola in in vertex form. So let's find the x and y-intercepts, same directions, for y equals x plus 2 squared minus 5. To find the y-intercept, if it was in standard form, all we would need to do would be to take the constant term, but this is in vertex form. So the y-intercept is a little different. We're going to sub in 0 for x. So y will equal 0 plus 2 squared minus 5. And 0 plus 2 is 2. 2 squared is 4. 4 minus 5 is negative 1. So the y-intercept will be 0, negative 1. The x-intercepts, I'm going to set the equation equal to 0. So 0 equals x plus 2 squared minus 5. Now when it's in vertex form, you do have a squared thing isolated. So I'll go ahead and use the square root method this time. So I'll add 5 to both sides to isolate the squared thing. So 5 equals x plus 2 squared. And then I want to take the square root of both sides, which gives me plus or minus the square root of 5 equals x plus 2. And then to solve for x, I will subtract 2 from both sides. And I get x equals negative 2 plus or minus the square root of 5. So I have those same two x-intercepts. So x-intercepts at negative 2 plus the square root of 5, comma 0, and negative 2 minus the square root of 5, comma 0. Remember, these are the same two examples we used last time, and they are the same parabola, so it's a good thing they had the same x and y-intercepts.